and I'm a nurse by background. For 30 plus years, I've been doing nursing in some form or fashion. I'm a NICU nurse. That is my experience, but we're going to be talking about things not specific to pediatrics, but dosage in general. Every now and then you'll see my little illustrations will veer off into NICU, but we'll work on getting you ready for the dosage test. A couple of housekeeping things. Please keep your mic muted if you would, unless you're specifically asking a question. Be aware that right now I think we have 40 people in the room. So I may not be able to answer all of your questions immediately because we have 2 hours and a boatload of material to cover. I'll do my best. If there's a burning problem that you just absolutely have to talk about, but we're just going to kind of move through this, hopefully at a reasonable pace. There wasn't anything you needed in advance. I'm going to put up some PowerPoints in a minute, and so you won't have to write the problems down. If you want to screenshot the screen, you certainly can. Also, for those of you that are in Pharm, you'll know that you have that Padlet board with lots of different options of videos to watch. And one of those is a recording of me doing this workshop where I go through these exact same problems. So we won't be recording tonight, but you can go back to that Padlet and find a recording of something very similar. The other thing to let you know is, again, if you have a question, you can put it in the chat, and I'll try to keep my eye on that. But have a little patience because I'm teaching the class, I'm monitoring the waiting room, and I'm monitoring the chat all at the same time. So, I'm good, but there are limits to how many things I can pay attention to at once. So that's kind of where I'm going. Someone's asking the recording. If you're in Pharm, then you should have received a link to a Padlet page that has all different kinds of recording. It's where you see the dosage, the basic dosage videos, and there's all kinds of supplemental videos from different instructors. If you can't find that, you need to talk to your instructor. It should be in your Blackboard page somewhere. So be sure that you find that out because that is a gold mine of information. So talk to your instructors. The way this course is set up, there is so many resources for you, but you just got to put your hands on them. And this is one. So that's kind of where we're going tonight. We are going to work through hopefully all the different kinds of problems that you'll need to know how to work to pass this test. One other thing, just to manage your expectations. You are, most of you, new at Pharm. You're in the beginning of this process. This next 2 hours will not be a miraculous experience where 2 hours from now you suddenly know how to work all the problems perfectly and can go make 100 on every test. Again, I am good, but I don't think there's anyone on the face of the planet that's that good. This is a process that you have to walk through, and you will bit by bit add layers to your understanding. So when we get to the end tonight, you may find the problems we're doing at the end you don't understand. That's okay. Hopefully, the problems we are starting with, you'll understand more than you did before tonight. So it's little steps forward. Keep working it, keep practicing it. You will master it. But be patient with yourself and be realistic about how much you can conquer in the space of an hour. Okay? And as I said, utilize all of the resources that you have in pharmacology. Again, talk to your instructors. Those of you that are in the online course only, the courses are all set up the same way. If you're in a face-to-face course, sometimes the courses, the organization of Blackboard is a little bit different, so you may have to talk to your instructor. But these are resources that are out there for all of you. Okay? Before I get going, any burning questions that you want to talk about? Anything that just cannot wait before we get going? Nope. Awesome. Okay, that's what I love. So I'm going to share my screen with you. Give me a minute to hopefully make all of this work. Okay. By the way, when I am in this screen, I can't see your chats. So you might have to turn your mic on if you have a burning question, okay? So dosage calculation, that's where we are. As I said, my name is Bev Bishop, and I want to talk first about some hints to begin. First of all, remember why we're here. By the way, would somebody turn your mic on? Just let me know you can see what's on my screen. Are y'all seeing this?
Not yet.
I can't see anything.
It said start screen sharing.
Okay, you saw that, but you aren't seeing the slides. Is that right?
Correct.
Yes, correct.
Oh, correct. Dang.
It's a blank screen.
Well, shoot. Hang on. See, these are the joys. Let's see if this works. Hold on. I do have plan B, so don't worry. Why are you doing this to me? Ooh. Okay. Now can you see it?
Yes.
Yeah. Yes.
Yes.
Okay. We're happy now. We're happy. Okay. Oh, I can even see your chats now. Lovely. Okay. So I want to start with some hints about taking the tests in general. And this, I know you want to work problems. We will work problems. But let me just say these details, if you don't pay attention to these, you can know how to work the problems and still fail the test. It happens over and over every semester. So pay attention to, if you're not a detail person, you're going to have to become one for the course of pharmacology. All right. You want to make sure you understand as much as you can what the problem is asking. I have some props I'll use tonight that will hopefully help. Just some terminology to make sure we're all on the same page. Doctor's order. All right. So this is the order the doctor has written to tell you how much medication to give. But for the purposes of tonight, every instructor may be a little bit different, but for the purposes of tonight, when I say doctor's order, what I'm talking about is how much dry weight medicine the patient is supposed to get. In other words, how many milligrams, how many units, how many micrograms, how many grains, how much medicine are we trying to put into this person? Now, sometimes the doctor's order includes a lot of other information, like about how to give it, what route to use, all of that. And that is a part of it. But for doing the calculations, when I say what's the doctor's order, I'm asking you, how many milligrams are we per person? Okay. Stock supply, dose on hand, those are terms that are interchangeable. And those are referring to, I don't know if you can still see my little photo here in the screen, but this is a bottle of Dayquil. And when I say dose on hand, what I mean is if I were to pour out a teaspoon of this liquid, how many milligrams of Tylenol is in that liquid? That information is what we call the stock supply relationship. It's the relationship between the amount of liquid and an amount of medicine. Likewise, here's a bottle of Tylenol. When I say dose on hand, how much medicine is in a tablet? Okay, and that always has to be given to you because neither of us were in the factory where they made these two things. So somebody's going to have to tell me, usually in the labeling, okay, how much medicine is in an amount of liquid, how much medicine is in a tablet. Okay, is that clear to everybody? Everybody with me?
Yes.
Okay.
Yes.
Good. Perfect. Okay. We're going to talk about some other things in a minute, but the last thing before I move on is I want to talk about dimensional analysis. By now, you have probably all either had at least one lecture or hopefully watched at least one video about dosage calculation, and you'll know that we use the method called dimensional analysis, which is a fancy way of saying that we use the units to help us solve the problem. So what that means is I go from beginning to the end, and I'm not really paying attention so much to the numbers, but I'm using the units, and the units will tell me what to do next when I get stuck. Okay? And then once I'm finished getting rid of units that I don't want, putting in units that I do want, then I can actually go back and do math. Okay, is everybody clear about what dimensional analysis is? And you've seen it by this point. You have some general idea of what I'm talking about. Yes?
Yes. Yes.
Anybody who's not clear about what dimensional analysis is? Awesome. Okay, so let's move on. Other testing, make sure that you are aware of your time. You have plenty of time, but not an unlimited amount. There's the details about you can only have a 4-function calculator, right? You can't have a programmable calculator, so get your 99-cent calculator if you don't already have it. You will have scratch paper, so you can write down the equivalencies if you're afraid of forgetting them. You have to memorize the equivalencies that have been given to you. You can't pass this test if you don't have them memorized. They will not be given to you in the test. Okay, so if you're worried you're going to forget how many milligrams are in a grain, as soon as you start the test, you can write that down. Other rules that we'll be talking about as we go through, there are rounding rules. Please hear me. This test will check to see if you know the rounding rules. In other words, it may give you the same answer, the correct answer, in 2 different forms. And only one is right because it's rounded correctly. So before you click on an answer, make sure you ask yourself, have I rounded correctly? I'm going to be giving you the rounding rules as we go through. They're very simple, but you just can't forget them. Okay? There's always something called leading and trailing zeros. Does everybody know what those are? Anybody need me to talk about those?
Yes, please.
You want me to talk about those?
Yes, please.
Yes, please.
Okay. This test will check. Do you understand what they are? Again, it'll give you the same answer twice, okay, to check to see if you know about leading and trailing zeros. So let's see if my pen works. A leading zero is like this, 0.1 milligram. Okay, that's a leading zero. That zero is there to mark the decimal spot. And if that zero is not there, the answer is incorrect. Okay, so let's say you got 0.1 milligram and answer A is 0.1 milligram. That's wrong because the leading zero is not there. Okay, so a leading zero, if the answer is less than 1 and it's a decimal, you need that zero. Now a trailing zero looks like this. 1.0 is a no-no. Can you see why? If someone's not paying attention and they don't notice that decimal, okay, then you might think instead of 1 milligram, it's 10 milligrams. Okay, likewise, as someone pointed out in the chat, this leading zero up here reminds me that this is not 1, but it's 0.1. Down here, I don't want the zero so that I don't get confused and think that it's 10 milligrams. Okay? So yes to leading zeros when necessary, no to trailing zeros. Questions about that?
Understood.
You would just put 1 milligram.
Good point. Okay.
Right? Yes, the leading zero is only when your answer is less than 1. Okay?
So do they require significant digit in this test, or we don't need to know about the sixes?
Are you talking about how many digits past the decimal?
Yeah, I mean, sometimes I see like in the answer, it's usually 0.7, but then sometimes I see 0.75 as an answer. So,
Yeah, we'll talk about it. Hold on to that. Those are the rounding rules, and we'll get there, okay? I don't want to jump ahead, because if I give you too much stuff now, it might not have context. All right, so these are the kinds of problems that we're going to walk our way through tonight. Hopefully. All right. Basic conversion problems, and I'm going to be moving fast to get through all of this. So once again, be patient. You can come back and watch videos later if you have questions about these. All right. So we'll talk about conversion problems. Then we'll go into dosage problems, and we're going to talk about simple dosage problems that have a weight element, dosage problems that have a time element. We'll talk about something called reconstitution. Then we're going to start talking about IV therapy. Okay, and we'll talk about maintenance IVs. We'll talk about IV piggybacks, and then continuous infusion medication drips. So there's a lot to cover in an hour and 45 minutes, okay? I'm going to do my best. Okay, so let's talk about conversions very quickly. Conversion problems should be the ones that you always get right. You don't have to set up the problem. These are the only ones that aren't word problems. They give you an equation, you solve it. All right, and you're going to do that because you know the memorized equivalencies. All right, you do not have to worry about rounding on the conversion problems because the answers will be given in a range. If you remember from the sheet you have in your textbook on conversions, when we convert from apothecary to metric, it doesn't convert cleanly. It's not a perfect conversion. And so, it will say a milliliter, something is 14 to 15 of something else. Okay. And hopefully your instructors told you only have to memorize one of those numbers. But somebody may have memorized another number. They may get an answer that's slightly different than yours, and that's why the answers on the test will be given in a range. Okay, everybody following what I'm talking about? I'll just turn my page and make sure that I'm on. So let's say it said 1 gram is 4 to 5 milliliters. Okay, so somebody might memorize 4, somebody might memorize 5, right? So that's why the answers will always be given in a range. So don't worry about rounding on the conversion problems. There will only be one correct answer. Okay, so let's work one real quickly just so that you get how this goes. So we get a problem like the first one you see on the screen, and you can probably solve this in your head, but I'm just going to show you how it looks in dimensional analysis. So we have 5 mils. Okay, we're going to put that over 1. Remember, you can always put in any number over 1. And what we are solving for is how many grams does that make? So when I look at this, I'm like, okay, I need to know how many mils are in a gram. All right, now, if you remember, there's an equivalency that you memorized that said 5 mils equals 1 gram. Well, that's pretty convenient. Okay, but you could also say a gram. Sorry, my handwriting here is 5 mils, right? Either one is true. So using dimensional analysis, I'm going to put my equivalency in. I want to be able to cancel mils, which means I need mils on the bottom. Okay, so I'm going to say 5 mils is 1 gram, and I want grams on the top because I want grams on the top at the end. Okay, now this is super easy. You cancel mils, you cancel mils. You can cancel 5 and 5, and so 5 mils is 1 gram. Now, like I said, you could have just done that in your head, but you see how the dimensional analysis is used in a more complicated problem. Okay, questions about that? Does that make sense to everybody?
I do have a question.
Yes.
Will we have to write out this, all the work for like a question like this?
These tests are on Blackboard. They are multiple choice tests.
Oh, okay. Got it. Thank you.
Right? That's why I said they gave you the answer in more than one form, just to check to see if you know what you're doing in terms of rounding. And you might think, oh, well, that's easy. But let me just tell you, they know the most common errors. And those answers will be there for you, right? So be careful. All right, y'all see what you can do with the next problem. Just real quickly, somebody tell me, what does GR stand for?
Grain.
Right. So for this problem, if you haven't memorized it yet, you need to know that 60 milligrams is 1 grain. Okay? So see if you can solve that problem, and somebody put your answer in the chat when you're done. Okay, bunch of you getting 10. That is correct. Any questions about that? Do you need me to work that?
I have a question on the ml. So, 5 ml equals to 1 dram, right?
Yes, that's correct.
Some places I see 4 to 5 ml equals to 1 dram.
Right. That's what we were talking about before, that apothecary to metric is not perfect conversion. Okay, so you can memorize 4 or you can memorize 5. Either way is fine. Just pick one of those numbers and memorize it. And so when you get to the test, the answer will be arranged so that for those people that memorized 4, their answer will be there. For those that memorized 5, their answer will be there. Okay?
Thank you.
So just pick one of those numbers and memorize it. All right. One thing. I'm sorry. Question.
I'm sorry. The 1/6 kind of threw me off on the grains 1/6 when I was trying to figure out the question. Would you mind going through that real quickly?
Yeah. So
Thank you.
the only thing about this is it's fractions. And if you haven't worked with fractions for a while, you need to go back and review how to work with fractions, because this is not, we're assuming that you know how to do that. And there is a section in your book on that if you're rusty. Okay. But basically 1/6 grain, okay, equals how many milligrams, right? And we're going to put our conversion in. We're going to put grains on the bottom because we want grains to cancel. We want 60 milligrams on the top because we want milligrams on the top at the end. Grains cancel. And then what you end up for math is 1/6 times 60. Okay? 6 goes into 6 once, 6 goes into 60 10 times. 1 times 10 is 10. All right? That is, okay? So again, that's just, and yes, question?
So what I did is this: 1/6 grain, I converted it to 0.2. That gave me 1/6 is 0.2 grain. So when I did 0.2 times 60 mg, I got 12.
Okay, so here's the deal. You can convert to to decimals. This particular problem, and that's why I put it in here, is not a perfect conversion. It converts to a repeating number, which means you're going to have to round, which means you won't get the same exact answer as the test, right?
Yes.
So just be aware of that if you convert it to a decimal and it's a repeating number, you may not get, you have to round it to get the answer that's on the test.
Yeah. Sorry, I don't know why this is confusing, because I already know what to do, but because you're getting the answer of 10, it was kicking me off my feet now. So are you trying to say if I have 1/6 grain in this kind of problem, I can round it to 0.2? Because when I did 1/6, I got 0.167. So I rounded the 6 to...
Yes, but wait, let me interrupt you. What you got is 0.16666666666666666.
7, yes.
Right? So you rounded, which means you didn't have the exact same number as 1/6.
Yes.
And that's why you didn't get the exact same number. You can do it. You can absolutely do it. It just means that you didn't get 10. right?
Yes.
You got 9.6 and you had to round up.
Okay, I just did another solution, which is fair. Instead of me to, what I did now is when I used my calculator to do 1/6, I got my 0.6667. I did not press the equal to, I just continued by times 60. It gave me
Gotcha.
10. All right, that's fair.
Okay, perfect. There you go. All right, let's move on because we got a lot to cover. All right, this next problem has another step to it. Capital T stands for tablespoons, right? OZ
Yes.
is ounces. The other symbol for ounce looks something like this. So it could be that symbol either. Both of those mean ounce. Now, when you look at this, you may say to yourself, I don't know how many tablespoons are in an ounce. That was not on my conversion list. Okay, so when that happens, what it means is it's going to be a multi-step problem. So let me give you an example with time. If I asked you how many seconds are in a minute, you could tell me. If I asked you how many seconds are in a day, you could get there, but you don't know that number right off the top of your head, right? You'd have to do a couple of multiplications to get there. So this type of problem, when you can't go there in one step, it's kind of like leapfrogging over a pond. You're on this bank, you're trying to get to this bank, you're going to have to make a little stop in the middle, okay? And most of the time, the stop in the middle, the common ground, is going to be milliliters because you know an awful lot about milliliters. I know how many milliliters are in a tablespoon. I know how many milliliters are in an ounce. So that's going to kind of be my common ground. Okay, so let me show you what that looks like. 2 tablespoons. I'm solving for ounces. Okay, so I told you my middle ground is milliliters. So I know that 15 milliliters is in a tablespoon. Okay, that's awesome. I've gotten rid of tablespoons. It may seem a little counterintuitive because I'm putting milliliters in when that's not what I'm solving for. But watch what happens next. What do I know? I know 1 ounce is 30 milliliters. You see that? So milliliters now cancels. And look at the units. I've canceled tablespoons. I've canceled milliliters. All that's left is ounces. That means I'm done with putting things in the problem. All I have to do is do the math. 2 times 15, come around to the bottom, divided by 30, the answer is 1. So 2 tablespoons equals 1 ounce. Okay, everybody following that?
I have a question.
Yes.
So I'm looking at the chart and it says 15 milliliters equals 1 tablespoon or half an ounce. So if we just did half an ounce.
Right. If you memorize that, you could do that too.
Okay.
Right. So again, it's how many things do you want to stuff in your brain at any given moment, right? So yes, you're right. You could have made it shorter by doing that. All right, so let's look at this next problem. Minimums and ounces. You don't have a conversion for minimums and ounces, right? But think about, what do you know? You know that 15 minim is 1 mil. And we've already said that 30 mils is an ounce. So see if you can solve that problem. Okay. The conversion chart is in your textbook. Once you get an answer, you can put it in the chat just so I kind of know you're with me. Okay, I'm not seeing a lot of answers. Are you still there? Okay, go back and look at what you did because 5 is not correct. Right, 0.16 is correct. Remember, I said you don't have to worry about rounding on the conversion problems. Okay? Anybody need me to work it? Did you figure out where you went wrong?
Yes, please.
Okay, so 75 minimums, right? And we're solving for ounces. So I don't know how many minimums are in an ounce, but I do know a lot about milliliters. Okay, so I know that 1 milliliter is 15 minim. Everybody understand why I put it in that way? Okay, so now minims cancels. Now I want ounces on the top, so I know that 1 ounce is 30 milliliters, and now milliliters cancels. So 75 divided by 15 divided by 30 gives you 0.16 ounces. Everybody see where you went wrong?
Yes.
Okay? All right, don't feel bad because that's how you learn. All right, let's keep going. So, question?
Yes. How did you know to put the ounce on top? Where
Because
75.
we want ounce on the top at the end. Right? This is ounces over 1. You can always put a whole number over 1.
Is the abbreviation for million is MX?
MX is minims,
Minimum.
right? It sometimes looks like this.
M and cross, yeah.
Okay? Don't have to worry about rounding. Okay? So, the way to memorize these, and I got to keep going because we're half an hour in, we got a lot to cover. But the way to memorize these is go to your workbook and work them. Just work a bunch of problems. And the more you work, the more familiar you'll become with those conversions. Okay? All right, let's keep going and talk about dosage problems. This is the bread and butter of all of the word problems that we're going to be doing. Okay, so the basic format is what you see in the middle of the screen. We're going to start. These are word problems. You have no equation to solve. Some of you may even be hyperventilating just thinking about word problems. Don't. If it's a dosage problem, you're always going to start with the doctor's order. And remember what I said. That means how much medicine are we trying to put in the person? That's it. 20 milligrams, 50 milligrams, 100 micrograms, 3 grains. How much are we trying to put in them? That's where I'm going to start. Okay. Then, this is super important, and it's super tempting not to do it. I'm going to leave a big empty space, and I'm going to put equals. And I'm going to put whatever the units the question is asking me to solve for. So, for example, is it asking me how many tablets? And I'm going to put tablets. Is it asking me how many milligrams? I'm going to put milligrams. Because remember, it's the units that are going to help me figure out what I need to put in the problem. And the units are going to help me figure out what not to put into the problem. Because as you'll see as we get further along, there's often more information in front of you than you need depending on what the problem is. How do you know what to use and what not to use? The units will help you if you use them. That's why we use dimensional analysis. Okay? Now, the other thing, notice at the bottom of the screen, 2 things that I want to emphasize. Run the math through your calculator 2 times. It's very easy to think you pressed the decimal button when you didn't. It's very easy to think that you pressed 2 and instead you pressed 5. Okay, so you should get the same answer 2 times in a row. The next thing that you need to remember, and here's the first of our 2 rounding rules. If it's a dosage problem, you're going to round to the 10th. That means if it's not a whole number, you're going to round so that there's only one number after the decimal, the 10th. So if you get an answer that's 5.46, you're going to round to 5.5. If you get an answer that's 5.43, you're going to round to 5.4. Okay, questions about that?
I just have a question then for conversions. Do we not have to round since one of them were 0.16?
Do not worry about rounding the conversions. There will only be one correct answer.
Yes, question here. If I have 5.43, why don't I just round to 5?
Because that's not as exact. And the rule says you round to the 10th, which means you're going to round to one number after the decimal place if it's not a whole number.
Okay.
In my world, in the NICU, half of our answers are less than 1, right? So we want to be as specific as possible, right? Okay, so let's work some. Here we go. So here's a very simple, basic dosage problem, but I just want to show you can probably do this in your head. It's okay. But we're learning a method right now. Okay, so let's read it together. The doctor orders medication B, 0.2 milligrams POQD. What does that mean?
By mouth every day?
Yes. So, along with those conversions that are in the back of your book, there also is a page of abbreviations. This is a new language. In order to understand these problems, you have to memorize those abbreviations. And sometimes the test, the only question will be something like, what route would you use? Right? You don't even have to do any math. So be sure that you've memorized those abbreviations. Okay? Now, the dose on hand is medication B, 100 micrograms per tablet. And the question is, how many tablets will you give for the correct dose? Okay, so this is a dosage problem. It's a word problem. I don't have an equation. I have to come up with the equation. So what we said for every dosage problem is we're going to start with the doctor's order. Okay, then we're going to put our destination. I know some of you are already there, but some of you aren't, so just be patient with me for a minute. Okay, and then we're going to let the units tell us what to do. Okay, so in this case, it's telling me to put 0.2 milligrams into this person. Is everybody clear on why I started there? Right? Doctor's order. That's how much medicine I'm putting in. Okay, what I'm solving for, remember, you're going to leave a little space. What am I solving for? What is the question asking me?
How many tablets?
How many tablets? So what I'm solving for is tabs. Okay, so now I have a problem to work with. Now, this is super important. We're going to come back to this again and again. When you get to the point in the problem where you're trying to get from a dry weight amount of medicine, like milligrams, micrograms, units, grains, we're trying to get to a form that we can actually put in a medicine cup, like tablets, milliliters. That's when you need the stock supply. There will be problems on these tests where you don't use stock supply. Okay, but a lot of times you will. And the way you'll know is when you're trying to get from dry weight medicine to a form that you can put in a medicine cup, that's when you need stock supply. Okay, so the stock supply here is 100 micrograms in 1 tablet. So I'm going to put that in. What's going on the top?
Tablet.
Tabs, why?
It's asking for tablets.
Because I want tablets on the top at the end, right? If I put it on the bottom, then how do I get it back on the top? Okay, so 1 tablet is 100 micrograms. Now, important note, Milligrams and micrograms are not the same thing. What do I know about milligrams and micrograms?
1 milligram to 1,000 microgram.
1 milligram is 1,000 micrograms. Again, you have to have that memorized. Okay? So now look what happens. Milligrams cancels. Micrograms cancels. And so now the only thing that's left is tablets. So that means I can do math. So 0.2 times 1,000 divided by 100 tells me that I'm going to give this person 2 tablets. I believe, oh gosh, Alyssa, you would ask me that. I think it's 20 problems. Don't quote me on that. I have to go back and look. I think it's 20.
25.
Okay. Any questions about this problem? Cool. All right. So now here's one for you. The doctor orders medication A, 1/100th of a grain SL stat. So somebody tell me what SL stat means.
Sublingual right now.
Right. Sublingual means under the tongue. So you might get a question like what route of administration? And the answer would be sublingual under the tongue. Okay? And stat, of course, means immediate. You all watch TV. You know that. The dose on hand is medication A, 0.3 milligrams per tablet. How many tablets are you going to give? So see what you can do with that. Okay, I'm not seeing any answers. How you doing?
2.
Okay, on at 2, that's correct. Just to be clear, you said by mouth. Sublingual is specifically under the tongue, like to dissolve under the tongue. By mouth, a lot of times that means swallowing, so just be careful.
So, sorry, the route of administration is going to be by mouth or sublingual?
Sublingual.
All right.
Okay, anybody feeling lost? Well, that's happy. Nobody piped up and said yes. Any burning need for me to work this, or can we move on?
I'm sorry, I was writing the question down. Yes, would you mind working it for me?
Okay, you want to talk to me about where you ran into trouble?
All I have written so far is the question.
Is what?
The question.
Okay.
So if I take a look at it, though, I have, I believe it's grains, 1/100 sublingual stat. Dose on hand is medication A, 0.3. 1/100th over, okay, over 1 time.
So don't feel like, one word of advice, you're not going to have time to write down all the problems.
Oh, okay.
Just screenshot it if you want to keep it. It's more important that you practice actually working it while we're in process, okay? So with every dosage problem, where do I start?
Doctor's order.
Doctor's order. Okay, so you got to know that. We always start, that's what we talked about a few minutes ago, always start with doctor's order. So in this problem, what is the doctor's order? How much am I trying to get into this person?
One over 100 grains.
Right. Does everybody see that?
Yes.
Okay. Right. Okay. So 1/100th of a grain, or you can convert that to a decimal if you like it better. And this one actually works very nicely to convert to a decimal, right?
0.01 grain.
Exactly. Right. So then you don't even have to play with fractions.
Yeah.
Okay. And then I'm solving for what? Tablets, right? Because the question was asking me here, tablet. Now remember what I said a few minutes ago. Okay. Grains is a dry weight measure. Tablets is something I can put in a medicine cup. Whenever I'm trying to get from grains to tablets, what do I need to get there?
1 grain over 60 milligrams.
But no.
Oh, sure.
Whenever you're trying to get from dry weight measure to a form that you can put in a medicine cup, what do you need out of the problem?
Stock supply.
Stock supply. Right? So whenever I want to know how much milligrams are in the tablet, I have to look on the bottle and read the stock supply. I can't memorize that because I wasn't there. I was not there when they made these tablets. Okay, so I'm going to put the stock supply in. I'm going to put tablets on the top because I want tablets on the top at the end, which means I'm going to put 0.3 milligrams on the bottom. But then some of you, those of you that are chess players, you can look ahead and see grains, milligrams. I can't cancel those, but I know that 60 milligrams is a grain because I memorized that. So now I can cancel grains, I can cancel milligrams. Okay, so 1/100th times 60 divided by 0.3 takes me to 2 tablets. Does that help? You're very quiet all of a sudden. Yes? Okay.
So I have a question.
Yeah.
I actually put the 60 milligrams over 1 grain before tablet over 0.3 milligrams and got the same answer. Is that okay? I mean,
yes. Yeah. And in these n-dimensional analysis, the lovely thing is it doesn't matter what order you put them in.
Okay.
You'll get the same answer. And if your mind works that way, that's fine. You can see it coming. You can see that you're going to need that conversion. That's fine. Right? I just want to be sure everybody knows why we put the stock supply in. So that when we get to problems where we don't use stock supply, you can understand. Okay? All right, let's move on. So now we're still doing dosage problems. We're still going to start with the doctor's order, but these are problems that we often say, for example, in pediatrics, where something is ordered by weight. What do I mean by that? I mean that if I'm in room number 1, and I don't know if you can see me on the screen, but I'm not a humongous person. And let's say that Shaquille O'Neal is in the room next to me, right? Somebody really big. Maybe the same dose would not be appropriate for him as for me. So maybe we need to account for the fact that he's 3 times as big as I am. Does that make sense? Okay, so the way you'll see that is it will tell you, for example, give Bev 1 milligram, let's just, for ease of understanding, 1 milligram per pound. Okay, now, am I going to get just 1 milligram?
No.
I weigh more than 1 pound. I don't know how to break it to you, but I weigh more than 1 pound. So in order to solve this, you need to know how much I weigh. Now, we just met, so I feel like that's a little bit personal. So we're going to imagine that Bev weighs 100 pounds. Okay? Okay? So in order to solve this, you're going to need to know how much I weigh. So when it's ordered by weight, you're going to need to put the patient's weight into the problem. But it's still a dosage problem. We're still going to run the math twice. We're still going to round to the 10th. All of the same rules apply. We just have this added component that this medication is ordered by a unit of weight. So for every pound the patient weighs, they get so much. Or for every kilogram that the patient weighs, they get so much medicine. Okay? So let's work one, and then I'll give you one to work. All right, so in this case, the doctor orders gentamicin 2.5 milligrams per kilogram of weight. So that means for every kilogram of weight, they get 2.5. It's going to be IV. What does Q8H mean?
Every 8 hours.
Every 8 hours. Okay. The vial of medicine is labeled 40 milligrams per ml. There's our stock supply. They have to give us the patient weight because we're not there. This child weighs 60 pounds. And then it's asking me how many mils are you going to give. So remember, it's a dosage problem. So I start with the doctor's order, which remember, now we've got a few more numbers here. But the question is, how much medicine are they telling me to put into this person, right? They're telling me to put in 2.5 milligrams, but is that it? It's 2.5 for every kilogram of weight. You have to have that in there because remember when I said give Bev 1 milligram per pound? If you don't put the per pound part in, then you're only going to give me 1. And trust me when I tell you that's nowhere near enough, right? So we have to put this in here to remind us that it's per kilogram of weight. Okay, then like always, we leave a space, we put equals, and we are solving for what? What are we solving for in this problem?
ml.
Ml. So we're going to put that there to remind us that's our destination. Okay, now, just like before, you'll look at this and you'll notice I have kilograms here. I don't have it at the end. That means I want to get rid of it. And the way to get rid of it is to put the patient's weight into the problem. Okay? So the patient's weight is 60 pounds. I'm going to put that in. But unfortunately, I can't cancel kilograms and pounds. But what do I know about pounds and kilograms?
2.2 kg, 2.1
Kilogram is 2.2 pounds. So once again, you have to know these conversions in order to solve these problems. Okay, so now kilograms canceled, pounds canceled. Okay, so now I got rid of all of that stuff. So now I'm trying to get from milligrams to milliliters. What am I going to need to go hunting for to get from milligrams to milliliters?
460. The vial of the medicine?
Right, the stock supply. So whenever, let me say it again, you're going to hear my little whiny voice. Whenever you're trying to get from milligrams, micrograms, units, grams, to a form that you can put in a medicine cup, like a tablet or a milliliter, that's when you need stock supply. Okay, so I'm going to put mils on the top, because I want mils on the top at the end. Okay. And I'm going to put 40 milligrams on the bottom. So now I can cancel milligrams. So now if I look at the unit, right, I got canceled, 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 canceled. Everything but mils is canceled. So that means I'm finished. All I have to do is run the math. 2.5 times 60 divided by 2.2 divided by 40. Okay, and you get, as many of you are saying, 1.7. Not 1.70. What's wrong with that?
The trailing zero.
Trailing zero. That would be incorrect. 1.7 mils. Okay, questions?
Yes. So 1.7 mil. Can't I round this to a 2.2 ml?
No, because the rounding rule says if it's not a whole number, you round to the 10th. That's just the rounding rule that you have to memorize. Okay? Because again, in my world, that can be a huge difference. Other question? All right. So here's one for you to work. The doctor, so again, don't write the problem, just start seeing if you can solve it. The doctor orders a loading dose of Lanoxin, 15 micrograms per kilogram, PO stat. We have a bottle of Lanoxin that is 0.25 milligrams per ml. The patient's weight is 200 pounds. How many mils will you administer? So I'll give you a second. See what you can do with that. The problems are getting a little longer, but don't let that throw you. It's not anything you haven't done. We're just sort of putting the pieces together. Okay? Once you get an answer, you can put it in the chat just so I kind of know that everybody's still with me. Okay, Sheena, close. Look at where your decimal is. Anna, that's correct. 5.5 is the correct answer. I'm going to give everybody else another moment just to kind of work through it. I know it's hard when I can't see your faces. I can't tell where you are in the process. So. Once you get an answer, put it in the chat just so I have some idea of. Awesome. Looks like everybody's kind of coming on board. That's great. Any burning questions about this? Anybody get stuck? Okay, Deidre, talk to me about where you got stuck.
So I did the 15 mcg over ml times 200 pounds over 1.
Right, 15 micrograms over kilogram. Excellent.
And I did 200 pounds over 1.
Okay, excellent. 200 pounds, okay.
And I did 1 milligram over 1,000 mcgs.
Okay.
I think that's where I got stuck at. And then I did the 1 over 2.2 pounds. So what I was missing was the 25 milligrams and then mLs.
Okay, so what you've done, and again, everybody's mind works differently, so I don't want to tell your mind how to work, if this makes sense, but so you put the pounds in. Let me get my little eraser out. Hang on, I'm going to erase a little bit. So let's finish off. You can't cancel kilograms and pounds, right? So we have to put our kilogram to 2.2 pounds in, right? Does that make sense?
Yes.
Okay, so kind of finish off with one thing before you go on to the next thing. Okay, so you look at micrograms to mils. You know I'm probably going to need the stock supply, right?
Right.
So let's go ahead and put that in, even though it won't all cancel yet. Let's get that in there. And we're going to put mils on the top, 0.25 milligrams on the bottom. So now I know that I need to put my milligrams over 1,000 micrograms. Okay, now again, you can do these in a different order, but you've got to have all the pieces, and it needs to make sense to you. Okay, so if it makes more sense to you to put the milligrams over micrograms in first and then put the stock supply in, that's fine. But you had this one and then you had this one. So it's kind of like, work your way through one at a time would be my suggestion.
Okay, thank you.
Okay? All right, let's keep going. So we have done dosage problems that were simple, that were basic. We have done dosage problems that had a weight element. Now we're going to talk about dosage problems that have a time element. What do I mean by that? I mean, is what we're talking about one dose, or is it an amount for a whole day? Okay, those are two different things, right? If I'm going to take 2 Tylenol, that's one dose. If I talk about how many I'm going to take in a day, I might say I'm taking 6 Tylenol in a day, right? But 6 is not one dose. So we have to be super careful that we understand whether we're talking about apples or oranges. Is it a single dose amount or is it the whole day amount? Okay, I'll show you what that looks like. One word to notice, sometimes these problems will use 24 hours. For me, that just puts another number in here. So you can switch that out and label everything as being a per day amount or per dose amount. I think that makes it simpler. Other people may have different ways to look at this, but you'll see what I mean in just a minute. The other thing to notice is when we're going back and forth between one dose and a per day amount, I need to know how many doses there are in one day, right? So like if I said 2 Tylenol per dose and I want to know how many you're taking in a day, I need to know how many times are you taking this. As, for example, Q8H. Okay, so if it says Q8H, how many doses are there in a day? 3. If it says Q6, how many doses are there in a day? 4. If it says Q12, how many doses are there in a day? 2. Okay, so just remember when you see that Q whatever, that you can figure out from that how many doses there are in a day. So, all right, let's work one. So this question says, give antibiotic A 500 milligrams IM. What does IM mean?
Intramuscular.
Intramuscular, okay. Q 12 hours. The vial reads, antibiotic A has 2 grams per mil. And the question's asking me, how many mils will the patient receive, but not just in one dose, in a full 24 hours? Okay, so in other words, let's just sort of to ourselves say, receive in a day. Okay? So it's a dosage problem, so I always start with doctor's order, 500 milligrams. Okay? So then I go over here to put in what I'm solving for, and I look at the question, and I notice that it says mils, but it's not just mils, it's mils per day. So I'm going to put that right there because that's super important for me to remember. Now, question, is the 500 milligrams an amount per day?
No.
No, that's just one dose, right? So I'm going to put a little note to myself here. That's one dose. Okay, so now, how do I get from milligrams to milliliters?
1 milliliter is also 2 grams given.
Stock supply, right? Stock supply. So mils over. Now this is 2 grams. Now if you're really quick on the draw, you'll know that 2 grams is the same thing as 2,000 milligrams. That'll save you a step. Okay, if you don't like that, you can put the 2 grams in and then put your conversion in again. Either way is fine. Okay, so this cancels. Now, am I done?
No.
No, because this is one dose and it asked me for the amount in the whole day. So how many doses are there in a day?
2.
2. How did you know that?
12.
Right? So that just reminds me, y'all are smart. You can see that just reminded me to multiply by 2. Now, if you can remember to do that without putting it in the problem, that's fine. But trust me when I tell you, one of the answer choices will be what you get if you forget this part, and it will not be the right answer. Okay, so 500 times 2 divided by 2,000, and some of you are already there. We're going to give 0.5 milliliters per day. Okay, questions? Everybody see what I did there?
Did we not round that one to 1 ml?
It's a dosage problem. What's the rounding rule for dosage problems?
Round to the 10th. Round to the 10th.
To the 10th.
Oh, okay.
Now, if it was 0.56, then we would round. Okay? Okay. Oh, what happened? Nothing. Okay. So, try this one and see what you get.
That's the same one.
No, it's not.
Okay.
Read carefully. Remember what I said about details?
Now we are looking for grams per day.
Yes.
Oh yeah, we're looking for grams. My bad.
Yeah, and I'm telling you, it's that kind of stuff that will come around and kill you. So I'm not trying to be smarty pants. I'm purposely, it's so much better to do it now when it's just us than when you're on the test.
2,000.
You're looking for grams per day. That's correct. Once you get an answer, you can put it in the chat. 1 gram per day, that's right. What'd you forget? If you didn't get 1 gram per day, go back and look at what you did, see where you went wrong. Okay, let's work it together. I don't want to leave you hanging too long because we got other places to go, right? So it's a dosage problem, just like all the other ones we've been working. We start with the 500 milligrams because that's how much medicine I'm trying to put into this person, right? And then I go to look at the question. It's asking me to solve for grams per day. Everybody see that? Grams in a day. Is 500 milligrams per day? No, we already said that's 1 dose, right? Okay, now everybody heads up. This is super important. Look at the units, milligrams to grams. How do I get from milligrams to grams? Somebody want to tell me?
1 gram is 1,000.
Right. 1 gram is 1,000 milligrams, right? Okay, so milligrams cancels. I can't be done yet because this is 1 dose and I'm looking for a per day amount. And so like we said before, there's 2 doses per day. Okay, dose cancels and I'm done. So 500 times 2 divided by 1,000 is 1 gram per day. Now, here's what's probably, for those of you that got 0.5, I'm sure you forgot this part, right? And the rest of you are going, wait a minute, what about the stock supply? I didn't use it. Why do we not need the stock supply? Remember what I said before. When do you use stock supply?
When it's in a liquid dose.
When I'm trying to get to tablets or to milliliters or a form that goes in a medicine cup, right? Or a syringe, right? That's when I need stock supply. But I wasn't solving for tabs or mils, was I? I was solving for grams. You didn't need, so don't chunk stock supply in just because it's there. Questions?
Yes, can you repeat that again about the stock supply?
I know, super crazy, right?
Yeah. Yes.
When do you use stock supply? You use stock supply in every problem so far. It's been asking us to solve either for how many tablets am I going to put in the medicine cup, or how many milliliters am I going to put in the medicine cup. But this question didn't ask either of those. It was asking me for grams. It was asking me for another form of a dry weight measure. So I didn't need stock supply. I already know how to get from milligrams to grams. If you put the stock supply in there, it's just going to add stuff in and screw you up that you don't need. So don't assume that you will use everything in the problem. There always has to be a reason why you're putting something in. Okay? I know. Time is fleeting. We got to keep going. All right. I'm just going to show you this problem because we need to keep going. I'm not going to, I'll give you the answer and work it later. But look at this problem. This one, the doctor's order was per day, and the question down here is asking me per dose. So it's exactly like what we did before, only in reverse, right? You would start with 30 milligrams per kilogram per day, and what you're solving for is mils per dose, right? So this question, question A, was per day, question B was per dose. So you just have to pay attention. What is it asking you for? Okay? All right, let me give you the answers to these real quickly, and you can work them later. The answer to question A is 11 mils. Oops, 11 mil. Oh, sorry, let me erase. 11 mils per day. And the answer to the second question is 2.8 mils in a dose. Okay, so you can work those out later on and practice. We got to keep going because we're going to talk about reconstitution. Reconstitution. If you have ever made hot chocolate, Gatorade, Crystal Light, any of those, you have reconstituted. It is nothing more than a fancy name for saying you have taken a powder, added a liquid, and made something else with it, right? So why are we teaching you about reconstitution? Most of the time, like for example, if you're working in the hospital, a medication is going to come up. I don't know if you can see my little picture down the bottom. A medication is going to come up from the pharmacy in what we call unit dose, which means it's already drawn up for you. It has a label. You can see a little label here. It's got a label on it that's got the patient name, the barcode, all of the information, et cetera, et cetera. Now, you still have to check it. You are legally responsible to check that that is correct before you give it, but it's been drawn up. However, there are some medicines, some antibiotics, for example, that are not stable as liquid. So what that means is you only want to turn it from powder to liquid right before you give it, which means it has to be done at the bedside. Okay, so in the NICU, for example, the way it works, I have an exhibit A here. In the NICU, what happens is they'll they'll send you up a little bag that looks like this. And inside, this is kind of well used, sorry about that. Inside this bag are 2 bottles. One of the bottles has powder in it, the medicine with powder. The other vial has what we call the diluent. It's whatever you're supposed to use, whatever kind of liquid, like sterile water, to put in the powder and turn it into liquid. And then on the side of the bag are the instructions about how to do that. That's all that reconstitution is. Okay? You're taking the powder, you're turning it into liquid, then you got to figure out how much to put in your handy dandy syringe so you can give it to this person. Okay? Questions? Does that make sense? Okay, so let's do one. So again, you can do this one in your head, but I just want to show you what it looks like. So the doctor orders 250 milligrams of antibiotic Z, okay? And the vial of power. It is the vial of power. It's really supposed to say powder, but you get it. It contains 250 milligrams of antibiotic Z. So it's in powder form right now, this medicine. Now, once it's liquid, it's going to be the same amount of medicine. When I put the water in, I'm not going to add more medicine. The amount of medicine doesn't change, whether it's powder or liquid. Okay, but one point before I keep going, let me just remind you, if you have a water bottle, okay, if you have a water bottle like this and it's filled up to the tippy top, and I open it up and I try to put Gatorade in here, what's going to happen?
It's going to overflow.
It's going to overflow. The powder expands and makes the amount bigger. Okay, so that's an important concept. Now, so the directions tell me that I'm going to reconstitute. That means I'm going to put 1.7 mils of sterile water into this vial. And when I'm done, I'm going to have 2 mils, right? So I'm going to end up with more water in here than I put in because the powder takes up space. Okay, so let's say that I couldn't just solve this in my head, okay, and I was working it, and it's a dosage problem. How many mils for the correct dose? That's a dosage problem. So I'm starting with the doctor's order, 250 milligrams, okay, and I'm solving for mils. And so remember what we said in the last slide. How do I get from milligrams to mils? What do I need to go looking for?
Stock supply.
Stock supply. What is the stock supply in this problem?
215.
What is in this vial once it's reconstituted?
2 ml?
2 mils. There's 2 mils, but that's not all. What else? How much medicine's in that 2 mils?
250 milligrams.
Right. Right? So in other words, they gave you all of the information you needed. They just didn't come out and say the stock supply is. Okay, but all of that information was there in the problem. So now I know that 2 mils is 250 milligrams, and of course you can cancel all of that, and you know the answer is 2. Okay, I just wanted you to show or to see that the stock supply is there. They just didn't label it as the stock supply. Okay? Now, what about this one? We're not going to work this whole problem, but let's say you're working this problem and you needed to know the stock supply. What is the stock supply here?
Isn't it 1,000 milligrams by 2.5?
It's 1,000 milligrams in 2.5 mils. In this case, they gave it to you. Do you see that? So in this case, I don't care that it's a 4-gram vial, and I never will use the number that tells me how much to put in. Now, if I'm actually doing it, I need to know that. But for math purposes, you'll never use that number. Okay, So in the last slide, if we back up, in the last slide, I had to put together what was in the vial and how much liquid it yielded to come up with the stock supply. But in this problem, they gave it to me. And you will see both kinds on the test. Okay? So if you're in a reconstitution problem and you don't actually see a stock supply described for you, that means it's one like this, where you have to put it together. Okay? Questions about that? All right, now we are going to stop for just a second because I want to talk about IV just a minute. All right? So ignore the problem on your screen and just look at my little drawings here at the bottom. We're going to talk about IV therapy for just a second because we're about to go into IV therapy problems. All right, so if you have a person that's NPO, what does that mean again?
Nothing by mouth. Nothing by mouth.
Nothing by mouth, right? So that means they're going to have to be on what we call a maintenance IV. I mean, in adults, it's going to be a big old IV bag, right? Because it's going to be giving them a lot of fluid, and it's going to be running continuously all the time to give them water and probably glucose and maybe some electrolytes and all that other good stuff, right? Okay, now let's say they're on an antibiotic, and that antibiotic is Q8 hours. So that means every 8 hours, we're going to come in with a little bag, little baby IV bag. Looks kind of, if you want to look at the screen, it looks kind of like this, little baby IV bag. Okay, it's got your medicine in it. And we're going to hang that, right? And we're going to let it run until the medicine's gone. And then we're going to come in and take that down, right? And the regular IV keeps running. Okay, makes sense? Now, we call this an IV piggyback. PB stands for piggyback because in this particular case, if the patient only has one IV, it is piggybacked onto the main line. In other words, it's sharing that same IV line. So IV piggyback refers to this little baby IV bag of medicine. Okay, you got it? Now, imagine that this IV bag is one of these kinds of medications where you have to mix the medicine in advance. I mean, where you have to mix the medicine at the last minute at the bedside. So that means I have this IV bag, but it has no medicine in it. It's just empty. It's one that has dextrose and water, glucose and water in it, right? So we might say D5W. That means dextrose 5% in water. So it's got sugar in it, but it's got no medicine. And then the pharmacy has sent me my little vials, right? One has powder, one has the diluent in it, right? So I'm going to make the Kool-Aid, and then I've got to figure out how much of this to draw up to the dose. Now here I have the dose in my little syringe. Can you see that? So I'm going to take what's in the syringe and inject it into this IV piggyback, and then I'm going to infuse the medicine. Does that process make sense? Okay, so notice there's two parts to this. The first part was I had to make the Kool-Aid and draw it up in the syringe. The second part is I take this IV and infuse it into the person. Got it? Okay, so let me erase all of this and let's read this problem. Give medication R, 75 milligrams, to be added to a 50 mil. That's just telling me how big this IV bag is. It's got 50 mils in it. 50 mil D5W IV piggyback. Okay, so in other words, once I've got the medicine in my syringe, that's what I'm going to do with it. The vial is to be reconstituted with 1 ml of sterile water to yield 125 milligrams per ml. So in this case, they gave me a stock supply. Okay, here's the question. How many mLs are we going to add to the bag for the correct dose? That means dosage problem. Dosage problems always start with a doctor's order. So what's the doctor's order here?
75 milligrams.
75 milligrams, okay? And what am I solving for?
Milliliters.
Right? The question's asking me for mils. That's what I'm solving for.
Yes.
Okay? How do I get from milligrams to milliliters? What do I need to go looking for next?
Stock supply.
Stock supply.
Stock supply. Okay, so 1 mil is 125 milligrams. Milligrams cancels and you're done. And as many of you already said, 0.6 is the answer. Now, notice I didn't care at this point how big the IV bag. That's part 2 of this process. Right now, I'm just figuring out how much to put in the syringe for the correct dose. And that's a dosage problem, right? And how do I round dosage problems? There's my lovely syringe. Aren't I a good drawer? Right? How do I round dosage problems?
10 to the 10.
To the 10. Okay, any questions about that? So even though this medicine was going to end up in an IV bag, this was just a regular dosage problem. Start with the doctor's order, round to the 10. Okay? All right, now on to IVs. So we've got a half an hour to do IVs. Everybody take a deep breath. Me too. Let me get a drink of water. Hold on. Okay, so IV therapy problems are just what you see on the screen. We are trying to figure out how to get IV fluid into a person at the correct speed. Too fast or too slow, too much or too little is a problem. Okay, so we're trying to figure out how much fluid to get in, how fast. Okay, now how will you know it's an IV therapy problem? Super easy. You will either be solving for mils per hour or drops per minute. Okay, so let's say I have this IV bag and I'm putting the tubing into an infusion pump. I have to tell the pump how many mils to give every hour. So that's why I would solve for mils per hour. Okay? Anybody else getting feedback? No? Okay. So, Leanne, it must be something to do on your end. Okay, so why would I solve for drops per minute? Sometimes IVs are running by gravity. In other words, there's no pump in between the bag and the person. So how do we know how fast it's going? Well, the way that we know that, I'm going to hold this up to the camera. This is what we call a drop chamber, a drip chamber. And you've seen it on TV, right? When they zoom into the IV and you see the little drops dripping, it's very dramatic, right? You know what I'm talking about? Okay, so if an IV is running by gravity, the only way I know to figure out how much fluid is going in is to count the drops. So that's why I would need to know how many drops are supposed to be going in per minute. Okay, and if I need to adjust that, there's different systems, but a lot of times you'll see something kind of like this. This is what we call a slide clamp. I don't know if you can see that. There's tubing in the end. I've cut the tubing off the other end. But it's a little roller clamp here. And if you roll it down, it slows down the dripping, if you roll it up, it speeds up the dripping. So it's very simple. This is for cases where we don't need to be very exact, right? Okay, but that's why you might need to solve for drops per minute. Questions about that? Okay, so just to summarize, if you're solving for mils per hour or drops per minute, it's a flow rate problem. If you are solving for anything else, it is not a flow rate problem. Okay, so when a problem comes up on the test and you want to know, is this a dosage problem or a flow rate problem? All you have to go do is go to the very last of the problem, look at the question. Are you solving for mils per hour? It's a flow rate problem. Are you solving for grams per day? Not a flow rate problem. Okay, is that clear to everybody? Because you need to know what kind of problem you're solving to know how to set it up. Okay, now here's the other thing you need to know. Notice down at the bottom, we are going to round all of our flow rate problems to a whole number. So here's the second rounding rule you need to know. All of our dosage problems, we rounded to a tenth. All of our flow rate problems, we're going to round to a whole number. And the reason the department chose to do that is because if you're counting drops, I double dog dare you to count a third of a drop, right? We need a whole number. So just to keep it simple, all of our flow rate problems we're rounding to whole numbers. Okay, the other thing you need to know is sometimes you will see something called the drop factor. And that has to do with how big are the drops that are coming into this drop chamber. Some IV tubing has very big drops. Some IV tubing has very small drops. Again, that's something they will have to give you in the problem because we don't have the package right here in front of us in the test. Okay, now that's a lot of information. It's not as complicated as it seems. Let's work a few and you'll see how this goes. Okay, we're going to start with maintenance IVs. Remember the ones I talked about, the big ones that are running all the time. And so what you're going to see is the doctor's going to tell you, give a certain volume of fluid over a time. Okay, so here we have our first flow rate problem. And the formula we're going to use for flow rate problems is volume. Remember, volume is an amount of liquid over time. Because remember, if I'm solving for mils per hour or drops per minute, those are volume over time. So if I want to end up with volume over time, I have to start off with volume over time. Sorry, my screen's a little slow. So mils per hour, that's a volume over a time, right? Mils is a volume, hour is a time. Drops per minute, that's a volume over a time. Okay, so we're going to start with a volume over time. So in this problem, the doctor has ordered 750 mils. I may erase all of this. Okay, to run in over 4 hours. Okay, so, and then they give me a drop factor. They tell me that every 20 drops makes up 1 mil of liquid. And so the first question says, calculate the flow rate in mils per hour. So again, volume over time. So my volume is 750, right? And my time is 4 hours. Everybody see that? Now, everybody heads up, pay attention. This is going to actually blow your mind. I'm solving for mils per hour, right? So look, Here we go. Heads up. Mils, mils, hours, hours. I don't have to do anything but take 750, divide by 4, and round it to a whole number, which gets me 188 mils per hour. Okay, everybody see that? So our formula is volume over time, and that's what I did. Easy peasy. Okay, now what if it asks me to calculate drops per minute? I still got to do volume over time, 750 mils over 4 hours. Okay, but this time I am going to have to do a little work because I'm solving for drops per minute. Okay, so I've got two things to do. I've got to get from hours to minute. I don't know why it's taking so long to paint. So 60 minutes in an hour, right? Everybody knows how I got there. Oops. Oops. Now what did I just do there? Did you see what I did there? I made a little boo-boo. Hours got to go on the top. Hour, 60 minutes. And see, that's where the units help you. Helps you get the right thing in the right place. So hours cancels. Now, how am I going to get from mils to drops?
The drop factor
would be the
drop factor. Right, that's how I'm going to get drops in the drum. So 20 drops per mil, and mils cancels. And again, round to a whole number, right? You get 62.5, but you're going to round up to 63 drops per minute. Okay, questions? Awesome. All right. So let's look at this one. The doctor orders 1,000 mils, so let's kind of draw it out. If you could turn your mic off, if you're not asking a question, that'd be great.
Yes, I am. I'm asking what was the answer to the last problem?
Oh, I'm sorry, 63. Okay. Okay, so the doctor orders 1,000 mils, and this is a two-part order. Okay, we're going to infuse the first 200 in 60 minutes, and then we're going to do in the remainder over 6 hours. Okay, so see what you can do with those two problems. Let me give you a second. Remember, you start off with a volume over a time. Once you get an answer, you can put it in the chat so I know you're with me. Okay, 50 drops per minute. That's the first answer. Excellent. Now see if you can solve the second one. Don't see any answers. 133, that's correct. Okay, so in the interest of time, let me jump back in here and we'll solve these together real quick. Okay, so remember, how do I know it's a flow rate problem? If I'm solving for drops per minute or mils per hour. If it's a flow rate problem, I want to try to use my shortcut formula, volume over time. Okay, so the first question is asking me for the flow rate of the first 200 mils. So the volume is 200, right? That's how much liquid I'm trying to give. And how much time do I have to give that?
6 hours.
No. How much time do I have?
60 minutes.
60 minutes. Right? Okay. And so it's asking me to solve for drops per minute. So minutes are good. The only thing I need to do is go from mils to drops. And how do I do that again?
15 GT by 1 ml.
Right, the drop factor. That's how I get drops in here. 15 drops per mil. So that's how I cancel mils and get drops. So 200 times 15 divided by 60, round to a whole number, and you get 50. Okay? Now for the second part of this, this is where it was just maybe a little tricky, but I wanted you to see how this works. I'm trying to do a volume over a time. So what is the volume and what is the time for that second question?
800
mils over 6 hours. Now, where did 800 come from?
1,000 minus 200.
Yes, right? If you'll notice, we started with 1,000. 200 is gone. So the remainder is what's left in this bag, which is 800. Right? So I just wanted you to see that. That number didn't actually appear in the problem, but they are expecting you to be able to think this through. Okay? And so just divide 800 by 6 and round to a whole number. Okay, questions? Excellent. Okay, so now the moment you've all been waiting for, right? IV piggybacks for an hour and 45 minutes. We've been building up to this moment. The thing to remember is in the IV piggyback, if you think back to what I said in the beginning, there's 2 parts to this process. The first part, if you look at my picture, was where you were making the Kool-Aid and you were drawing it up in the syringe, right? Remember how we did that? And it was a basic dosage problem. And I said it didn't matter at that point that it was going to end up in an IV bag. It was still a basic dosage problem. Now, once I've got my medicine all mixed up and I'm trying to calculate a flow rate, then I'm going to try to use my volume over time formula and round it to a whole number, because that's the flow rate part when I'm trying to actually get the medicine into the person. So your mission is when an IV piggyback problem comes up, you've got to figure out which part of the problem are you doing, and that will tell you how to solve it. So let me show you one, and then I'll let you do one, okay? So there's a lot of words. Don't let that throw you, okay? Give medication Q 50 milligrams, right? There's our amount of medicine. We're going to end up putting that into a 50 ml bag of D5W IV piggyback, and we're going to infuse that over 30 minutes. We're going to do that Q 6 hours. Okay? The vial is labeled medication Q 1 gram. We got to reconstitute this thing with 19.5 mils of still water to yield a volume of 20 mils. So lots of words. Don't let that, you'll be able to figure out what you need. The first thing we want to do is figure out, is this a dosage problem or flow rate problem. So let's look at the question. How many mils will you draw from the vial for the correct dose? So you tell me dosage, flow rate.
Flow rate.
Okay, why would you say flow rate?
Dosage.
How can you always tell if it's a flow rate problem?
Flow rate will have drops per minute or milliliters per hour.
Remember, flow rate is always mils per hour or drops per minute. If you're solving for anything else, it's not a flow rate problem. Is that clear? Even though it's going to end up in an IV, the part of the problem we're doing is not the flow rate part. Okay, so that means I know this is a dosage problem, and we've worked a million of them in the last hour and 45 minutes. So that means I start with the doctor's order. That means I round to what?
The whole number.
10.
The 10th.
Dosage problem, you round to the 10. Right? So before I even started, I already know where I'm going to start with the doctor's order. I'm going to round to the 10. Okay, because it's a dosage problem. So what's the doctor's order? Out of all those numbers, where am I going to start?
50 milligrams.
Right, because 50 milligrams is how much medicine I'm trying to put into this person, right? All the rest of it is instructions about how to do it, but this is how much medicine I'm trying to get in them. Now, what am I solving for? What's the question asking me to solve for?
mLs.
Mls.
Okay, so now I have something to work with. How do I get, remember my whiny voice, how do I get from milligrams to milliliters? What do I need to go looking for?
Supply.
Stock supply. So I know I need stock supply. So what is the stock supply?
20 ml. 20.
Is that it?
By 1 gram.
Yes.
1 gram.
So the stock supply tells me there's 20 mils in the vial and there's 1 gram of medicine in that vial. Everybody see where that came from? Okay. So now I've got grams and milligrams. So I got to convert 1 gram is 1,000 milligrams, right? Everybody knows how that works. I'm going to cancel milligrams. I'm going to cancel grams. Okay, what's left is mils. And so now I'm done. So 50 times 20 divided by 1,000. How many mils will I draw from the vial for the correct dose? 1. Now, notice there was a lot of information I didn't use. Don't let that mess with you. You figured out what kind of problem it was. You knew how to set it up. And then the problem told you what you needed next. Okay? Now, here's the same problem, different question. Is this a dosage or a flow rate problem?
Flow rate.
Flow rate. Flow rate, right? It says it. That's very helpful. But you also know you're solving for mils per hour. So I'm going to try to use volume over time. So now I need to go, I'm thinking about what's in this IV bag. How much liquid's in it? How much time do I have to infuse it? Okay, so what is the volume of liquid I'm trying to get in?
50 milligrams.
50 ml.
Right, how much liquid's in this IV bag? It's 50. 20 is what's in the vial of medicine. I'm not giving all of that, right? I have got a bag now that's got my medicine in it, and I'm trying to infuse it. So 50 mils are in this bag. Now the next question is, how much time do I have to infuse this?
6 hours.
30 minutes.
Okay, this is tricky. There's 2 times here.
30
There's
minutes.
30 minutes
30 minutes.
and there's 6 hours. Which one is my infusion time?
30 minutes.
30 minutes.
Right. What is the Q6? What does that tell me?
Every 6 hours.
So, because this medicine is intermittent, I need to know how long to infuse it, but I also need to know how long before I do it again. So let me give you an example. This is Q6. So let's say 6 a.m., I'm going to hang this. It's going to run in from 6 to 6:30, 30 minutes. Okay. Now, 6 hours later at noon, it's going to run in from 12 to 12:30. 6 hours later, 6 p.m., 6 to 6:30 p.m., and so on. Do you see what I mean? Okay. So the first time is your infusion time. The second one's the frequency. Okay. Now I'm solving for mils per hour. So notice I've already got mils. All I have to do is 60 minutes in an hour. And I'm done. Okay. Now, how am I going to round this?
Whole number.
Nearest whole number.
Whole number, because it's a flow rate problem. Okay, so on the test, when you get these IV piggyback problems, you've got to figure out, are they asking you this part, the dosage part, start with the doctor's order, round to 10? Or are they asking you the flow rate part, how big is the bag, what's my infusion time, round to a whole number? Okay, now, your mission, should you choose to accept it, is to try this problem. Now, I want you to notice this one has medicine ordered in units. Don't let that fool with you. A unit is just another way of measuring medicine. It could be milligrams. Okay, treat it just the same way you would milligrams. So the first thing you want to ask yourself is this a dosage problem or a flow rate problem? And that'll tell you where to start. Okay, so I'm going to give you a minute to kind of think about it. And see if you can solve it. What'd you get? 0.5. Ooh, that is correct. I'll give everybody else who's not speedy time to fool with it. Awesome. A couple more people coming through. I know we're into the more complex problems, so if this is kind of blowing your mind, just relax. You'll get there. Okay, let me just talk it through with you. But I just want to make sure everybody knows from reading the question, what type of problem is this? Dosage or flow rate?
Dosage.
Dosage. Is there anybody that was unclear about that? Okay. How do we start dosage problems?
Doctor's order.
Doctor's order. So how much medicine are we trying to put in this person?
1 million units.
1 million units. That's kind of crazy, but there it is. Okay. And what are we solving for? It's asking me for mils. Right? So how do I get from dry weight medicine like milligrams, units, grains to mils? What do I need to go looking for?
Apply.
Stock supply. So what was your stock supply in this problem?
10 milliliter over 20 million units.
Right. Once the vial was reconstituted, you had 10 mils in it, and the amount of medicine was, remember, a stock supply, two numbers. Okay, so now units cancels, and then we can get rid of some of these zeros, right? So 10 divided by 20 is 0.5. Okay? Does that make sense to everybody? Okay, so see if you can solve the flow rate part. Once you get an answer, put it in the chat just so I know you're with me. Volume over time. $125, that's right, Alyssa, excellent. So just to summarize, for those of you that are kind of teetering, when it's the flow rate part, I need to go looking for how big this IV bag is, how much fluid's in the IV bag, and how much time do I have to infuse it. So in this case, I'm trying to put this medicine in a 250 ml bag. And remember, there's two times, 30 minutes, 4 hours. Which one is my infusion time?
30 minutes. 30 minutes.
30 minutes, right? The Q4 tells me how often to do it. Okay, and I'm solving for drops. Oh, sorry. Yeah, drops per minute, which means I need the drop factor, which is 15. Now, do you notice how, one thing I want you to notice, even though there's a lot of words, the actual, I'm letting it finish painting. Yeah. Even though there's a lot of words, the actual problem is short. Right? And we round to a whole number. Okay, I've got 2 minutes left. I've got one thing left to show you. So let me just summarize real quickly.
What was the intake? 25?
Just to summarize, a dosage problem. Right, we're going to start with the doctor's order. We're going to round to the 10. Okay, we may have to pay attention to whether it's one dose or 1 day that I'm talking about. Okay, but all of those are things we know about dosage problems. For flow rate, I'm going to try to use my volume over time formula. Okay, I'm going to round to a whole number. Okay, and I know it's a flow rate problem because it's mils per hour or drops per minute. Okay, now got 1 minute left. Let me show you something really important. let me get to the last one. Oh, I don't know if it's going to let me erase this from another time or not, so just ignore that. Okay, so let's look at this problem. The doctor orders dobutamine, 500 milligrams, and 1,000 mils of D5W to infuse at 10 micrograms per kilogram per minute. The patient weighed 175, we got a drop factor, there's a lot of information there. It's a flow rate problem. Okay, everybody see that? So, per hour. So whenever possible, I like to use my volume over time formula. It makes it very simple. So I go looking for a volume. Well, it's 1,000 ml bag. That's good. That's a volume. Somebody tell me how much time I have to infuse that 1,000 milliliters.
Is it the 10 kilograms per minute?
Well, here's the thing you need to know. There's no time given for the whole bag. Do you see that? Nowhere, like you remember our other problems where it says give, 1,000 mils over 4 hours? There's no time given for the whole bag. The only time in the whole problem is right here. And I have to have a time in a flow rate problem because my answer has a time in it. So when you see a problem like this, it means I can't use my volume over time formula, my volume over time shortcut. I'm going to have to go the long way, which means I have to start with the only time I have, which is 10 micrograms per kilogram per minute. Now, these problems are the ones that get super long. But it's not anything we haven't done in the last 2 hours. Okay, so hang on, I'm going to erase for a minute and work it down here at the bottom. Okay, so let me just show you this real quick, I'll let you go. So 10, I couldn't use volume over time because there was no time. So I had to go the long way with the only time that I have, 10 micrograms per kilogram per minute. Okay, and I'm solving for mils per hour. Okay, so what do I see here? I see kilograms. I remember how to get rid of that. I get rid of it by putting in the patient weight, right? Then I have to do my conversion. A kilogram is 2.2 pounds. So now I got rid of pounds and I got rid of kilograms. That's good. Okay, so whenever you don't know what to do, look at your units. So now I've got minutes and I need to get to hours. I know how to do that. 60 minutes is an hour. Okay, that's good. So I got rid of minutes. Okay, so I've gotten rid of a lot here. But I've still got to get from micrograms to mils. Now, whenever I was doing a dosage problem and I needed to get from micrograms to mils, I used the stock supply. Well, in this case, what's in your bag becomes your stock supply. You've got 1,000 mils, and in that 1,000 mils, you have 500 milligrams. It's almost like you're pulling out a little bit of medicine every minute. Okay? Now, I can't cancel milligrams and micrograms, so 1 milligrams, 1,000 micrograms. Micrograms cancels, milligrams cancels. Okay, so now, I know our time is done, but let me just show you. So cancel, 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 hour, mils, cancel, cancel, cancel. So everything is canceled except mils per hour. So that means I'm done. So now you have to run the math. 10 times 175 times 60 times 1,000. Come back around, divide by 2.2, divide by 500, divide by, what is that, 1,000, right? Now, am I going to round to the 10 or am I going to round to a whole number? What kind of problem is this?
Whole number.
Whole number, because it's a flow rate problem, right? And anybody run the math? The 95. One little hint, you can do this on your calculator in one swoop if you want to. Here's what you do. You go 10 times 175 times 60 times 1,000. Do not press equals yet. Then come around to the bottom, divided by 2.2, divided by 500, divided by 1,000 equals. Right? That might save you a little time. Okay, questions? I know I've gone 5 minutes over. I apologize for that, but I wanted to show you these problems that are the exception to the volume over time rule. Okay? All right, how you feeling?
Thank you.
So much stuff. I know, it's a lot. It's a lot. Focus on one type of problem at a time. See if you can kind of master that and then move on to the next type. You will get there. Don't worry. You have 4 chances to pass this test, so you've got a couple to give, right? Okay? I wish you the best of luck. Practice hard. Practice, practice, practice. You will master it. All right?
Thank you so much.
Be sure to reach out to your professors. Okay?
Thank you so much. Thank
You're
you so much. Have a
welcome.
great night. Really helpful session.
You too. I hope it was helpful. Y'all have a great evening.